thing which you see, thing you touch, and thing you smell have one thing common, and that is atom. Means indivisible. Ancient Greek philosopher Democritus once popularized that if you cut a paper a half, then in a half, then again in a half, you reach at a point. That point is called as atom. Means indivisible. You cannot more cut that point into one another. In 19th century, we zoomed into atom and see that negatively charges revolving around a dense positively charged nucleus. If we unwrap the nucleus, we see that there is a proton and there is a neutron, the two subatomic particles. Despite of lacking structure of electron, proton is further zoomed into it. We see that proton is made up of tiny colorful balls of reality. These balls are called as quarks. It is very difficult for us and physicists also to remember each and every particle by name. So physicists introduce a periodic table. No, that kind of periodic table is another thing. Generally, in periodic tables, we arrange elements. But in this table, we categorize ultimate building blocks of reality. This table is called as Standard Model. This is standard model. Top two rows are termed as quark. As you zoomed into proton, you see tiny colorful balls which bounded together by glue. Wait a minute. Glue? Please teddy bear, put on besides glue. Okay? On besides glue. This is glue on. We talk about a bit later. Three sets of each pair of quarks. They have silly names: up and down, top and bottom, and charm and strange. Scientists named due to their color. For example, blue, red, and green. They combine in such a way that resulting color is colorless. Like two up and one down combines and creates a proton, while two down and one up resulting into a neutron. Quarks have a spin and electric charge also. Quarks don't hang out, they just bond into the proton and they not free to move. The bottom row of the standard model is lepton. Lepton? I think Lepton tea is made from this lepton. So by the way, this is a different thing. Lepton tea is just a tea. It's lepton. Bottom of the table, there are three leptons. The most commonly known lepton, guess what? Electron. Leptons are also termed as matter particles. They are massive than quarks little a bit. First three are electron, muon, and tauon, and second three are their neutrino version. Electron neutrino, muon neutrino, and tauon neutrino. Electron is crownless king of the physical sciences. You all know it is like our family member. In molecules or in atoms, there is an electron tied up in a chemical bond and move in the lattice of a unit cell. Its smallest charged particle and very stable. Remaining two are the unstable versions of electron. Muon is 207 times heavier than electron. It decays in just 2.20 seconds. And what is the source of muons? These are cosmic rays. Cosmic rays discovered mid of 20th century. What the heck? Teddy bear, have you edited it? This is possible physically. That how do muons are coming from the cosmic rays which just have 2.20 microsecond life? This is a long distance. How do they reach Earth in less than 2.20 seconds? I am just suck off physics. Aha, Einstein. According to special theory of relativity, muons travels close to the speed of light. Therefore, time dilates for them. So they reach Earth in just 2.20 microseconds. By the way, tauon is considered to be the sumo wrestler of the lepton family. These particles are 3,490 times bigger than electron. It found in high energy particle physics experiment. Each lepton discussed earlier has a cousin called neutrino. They are electrically neutral particles and they are very much smaller than electron, or considered to be approximately massless. Did you know millions of neutrinos still passing from my tablet screen just right in microsecond? Because neutrinos are very shy particle, the lepton family. They are very less massive, so we cannot even feel or not even taste. Next topic is gauge boson. What are gauge bosons? They are also called advector boson. But wait a minute, what is boson? This is the perplexing question also. All these particles which we have discussed in the standard model up till now are useless, meaningless. There is no need for them without discussing the agent which causes interaction between them. That agents which unite fundamental particles, for example quarks and leptons, to form heavy particles, fermions and hadrons, are called as bosons. We categorize boson into two. One is vector boson and other is scalar boson. This is just a nomenclature. You cannot seriously take a word vector and a scalar. They have directions, others have not. Two matter particles interact with each other with the massless force carrying particles called gauge boson. These are also named as vector boson. Right now you see me. Yes, you can see me due to the first gauge boson called as photon. What is photon? Photon is a light carrier particle which is a carrier of the electromagnetic force. Light emitting diode excites and de-excites the electron lepton in p-n junction, which emits a visible range photon of characteristic colors. That photon sensed by the retina of my eye, then you see me. They are massless. Photons travel at the muzzle speed of 186,000 million miles per second. You can complete your 9 rounds around the earth if you travel at the speed of a photon in just a single second. Photon emits when the electric charge accelerates or decelerates in an electric field, or is also generated according to the Butterworth model. If one electron in the high energy shell goes down from the lower energy shell, therefore they emit a photon in a characteristic wavelength. This is also a characteristic of a particular element. The second one is gluon. Gluon glued cork together. Make it right, teddy bear. This is gluon, not glue. It is a carrier particle of a strong interaction, and it unites or accumulates two or more than two quarks into a proton or hadron more precisely. When electron and a positron is an antimatter particle of a electron, a version of electron according to the theory proposed by the Paul Dirac in 1920s, that every particle has their antiparticle. So this standard model has also have some anti-particle version of this. If positron and electron annihilate, they emit gluon, which can be easily understood by the Feynman's diagram. Did you know who is Feynman? If you don't know Feynman, then you should quit this video because you don't know the tiger of the particle physics. Yes, it's true. You might have studied the following reaction in your grade 10. Uranium converts into thorium. Then how it is possible? Yes, here is come the W and Z boson. These are the force carrier particles of the weak interaction from which the nuclear conversion takes place. These force carrying particles have their charge and also are massive. So W boson is of two types, W plus and W negative, and their cousin Z naught, Z boson, is also electrically neutral. But the question remains the same. What is weak nuclear force? The star burn is due to weak nuclear force. The atomic bomb is due to weak nuclear force. And from the atomic level to the large scales of black holes, there is a weak nuclear interaction between the tiny particles. This is the force which interact between atoms, protons, quarks, and all this stuff. Surprisingly, they are massive. According to particle exchange theory, force carrier particles must be massless. Where do the W's and Z's bosons mass come from? I am very sorry to say gravity is excluded from the standard model due to its long range nature and ineffectiveness in the quantum scale. But the theoretical physicists pointed out that there is a hypothetical particle called graviton, which is considered to be a vector boson and a carrier of the gravitational force, like quanta of gravity. The second one is a scalar boson. There is only one scalar boson which you all know. Guess what? Higgs boson. This is just to interact with the massive force carrying particle and give them a mass. In 1979, physicists like Abdus Salam, Weinberg and Glashow realized that photon, W and Z bosons are collectively one thing. For example, physicists like Abdus Salam, Glashow and Professor Weinberg just realized that photon, W and Z boson are just a one thing, one force which seems to be different. For example, this is a teddy bear. If you see the teddy bear from this side, this is different, and from this side this is different, but teddy bear is just a one thing. For example, this is a photon and this is a W and Z boson. But these all the things are just one thing, one force. Therefore, the all forces are lie on this teddy bear. So photon and W and Z boson are the different things, by the way. So this particle has been discovered in 4 July 2012 in Large Hadron Collider at CERN. Peter Higgs also awarded a Nobel Prize in Physics for his astonishing discovery where the masses of the W and Z bosons come from. All massless particles travel smoothly from Higgs field, but only massive carrier force particles interact with the Higgs field, and the quanta of the Higgs field is called as Higgs boson. All these particles except boson have the anti-particles version, which is also considered to be an anti-standard model, and it's also true according to Paul Dirac. Tell me in the comments what are your views about this standard model. Like this video, then must like it. Wait, follow me on Patreon to make such kind of fascinating videos possible. Up till then, bye bye.